Welcome to this session on design for manufacturing software. Today I'm going to explore the various DFM tools that can streamline product development by integrating manufacturing considerations early in the design process. This emergence of the DFM is a critical practice within engineering design and industrial production. It fundamentally reshapes how products are conceptualized, developed, and delivered. It emphasizes early integration of manufacturing perspectives into the design process to reduce costs, minimize complexities, and overall product quality. The presentation, titled Design for Manufacturing DFM Software Enhancing Product Development, is going to aim to unpack the value of the software-driven DFM tools by focusing on leading platforms. The goal, however, of this presentation is going to provide a comparative overview of the DFM software solutions, analyzing their capabilities and illustrate how they're being used across various industries to reduce the rework, accelerate time to market, enhance design reliability through case studies, technical comparisons, and in-depth discussion of the DFM principles and deliver actionable insights for for engineers, product managers, and design makers involved in the design and manufacturing. Here is an overview of the agenda. Uh, the structure of this presentation is designed to facilitate a progression of ideas that are going to allow not only the newcomers but also experienced practitioners to grasp the scope of the DFM softwares that are out there. It's going to begin with the fundamentals of design for manufacturing in order to set the stage for a more nuanced discussion of the technological interventions, that being the software tools that have enabled DFM implementation. Following that, we're going to dive a little bit more into depth about each tool and and discuss in terms of its technical architecture, integration capabilities, and support use cases and impact on the design workflow. Lastly, we're going to have a comparative analysis of the differentiators across each of these platforms. And I believe that this would be very crucial in helping, teams, manufacturers select the right tool based on their organizational need, product type, and production environments. Lastly, we're going to conclude by summarizing key takeaways and provide a guidance on how organizations can initiate and enhance their DFM initiatives. As stated previously, this first section is an introduction to DFM to help set the stage. DFM revolves around several key principles, first of which is simplicity, simplifying product designs by reducing the number of parts. Minimizing complexity can lead to easier assembly, lower manufacturing costs, and simplified designs are less prone to errors and often result in more reliable products. Number two, the standardization usually is merely amounts to utilizing standard components and materials whenever possible to reduce costs, simplify inventory management, and facilitate easier maintenance and potential scalability. Next is process capability considerations. With that point, designers need to understand that capabilities and limitations of manufacturing processes need to ensure that designs are feasible, cost effective to produce, including tolerances. This includes tolerances, material properties, and tooling requirements. Design for assembly, DFA. While DFM focuses on the manufacturing processes, DFA emphasizes ease of assembly. The integrating these DFA principles ensures ensures that the products are not only manufacturable but also easy to assemble. This further reduces the labor cost and assembly time. Early involvement in manufacturing teams. I put this in here as I think this is also a critical matter. The engaging of these manufacturing experts early in the design process allows for a valuable feedback, ensuring that the potential production issues are identified and addressed promptly, as opposed to midway. Moving over to the significance of DFM, there's cost reduction, identifying, eliminating potential manufacturing issues early. Companies can avoid expensive redesigns and product delays. There's also improved product quality. Designs, designs need to be optimized for manufacture. Designs optimized for the manufacturing are less likely to encounter defects, leading to a higher quality product. Faster time to market. Streamlined designs that are easier to manufacture can accelerate the product production process, allowing products to reach the market more quickly. And enhanced collaboration kind of goes back to DFM, how DFM fosters this collaboration between design and manufacturing teams, promoting a more integrated and efficient product development process. Now we begin with our second session here, where we're going to dive into a deep analysis of the platforms that were previously discussed that aid in the DFM processes that manufacturers use, and the software themselves. First of which is DFM Pro. That's developed by HLC Technologies. It's a CAD integrated DFM solution designed to identify and rectify manufacturable issues early in the design phase. It integrates seamlessly with leading CAD platforms such as SolidWorks or CATIA V5 or NX, and this in turn allows the designers to perform DFM checks in their CAD in their native CAD environments. The key features of the DFM Pro by HLC Technologies include a comprehensive set of design rules derived from industry best practices, covering processes like machining, injection molding, casting, sheet fabrication, and assembly checks. The rules that they have established help ensure that these designs meet manufacturing process capabilities or supplier specific requirements. As you can see in the image two below, is an example of the said software. Regarding back to the rules, as such, custom DFM, the rules that they have established here have a custom DFM guidelines, checklist, custom CAD rules, report generations, and even for the custom rules, while ensuring the confidentiality and proprietary rules and best practices. For instance, the injection molding uh, issues with injecting molding are wall thickness, cutout area, boss parameters, rib parameters, mold wall thickness, draft angle, min and max walls, and that these rules that they have in the software checks for these issues. The software alone offers an early visibility into the manufacturing and cost implications that enables the designers to inform decisions that reduce rework, manufacturing cost, and time to market. According to HLC Technologies on their website, implementing this DFM Pro leads to a 20% reduction in work and rework, 12% decrease in manufacturing costs, and a 10% improvement in time to market. Uh, its integration with these CAD platforms allow for a real-time feedback and visualization of the DFM analysis results in a more of a natural environment, this 3D environment that's like that in turn facilitates a more of a intuitive and cost-effective design validation. I would say in some, this software, the DFM Pro by HL Technology, I would say it serves as more of a powerful tool for enhancing the engineering productivity, reducing product development costs, and ensuring high quality outcomes by addressing the manufacturing issues early in the design process. Moving over to our second platform is Vio Pro DFM Expert. It's an intelligent DFM or DFA analysis tool. It's tailored for electronics manufacturing, particularly focusing on the PCB and assembly. It's important. It imports these PCB designs and BOM data, bills of material data, and interacts with the parts libraries, performs comprehensive analysis to identify the potential manufacturing defects, uh, even before production. Now, this software alone encompasses over about 15,000 checking rules and these checking rules are based on industry standards covering aspects such as component placement, soldering, and assembly processes, and that these rules in turn help detect design defects early, which thereby reduces prototyping timing and cost. The software also further supports multiple design formats and provides advanced 3D reporting capabilities, enhancing communication, which in turn enhances the communication between design and manufacturing departments. Uh, the reports also that are generated from the software also facilitate better understanding and collaboration that in turn ensures more of a it ensures that the design queries are effectively communicated and addressed. Additionally, the software here allows for customization of the reports to meet specific requirements, which further improves its adaptability for various organizational needs. By simulating and analyzing the potential defects prior to manufacturing, which is a key component of what the software offers, uh, in turn will ensure that these designs comply with the manufacturing standards, ultimately leading to an improved product quality and reduced time to market. Our third platform here is DFMA by Boothroyd Dewhurst. It's a comprehensive software tool that combines design for manufacturability and design for assembly methodologies in order to streamline product design, reduce costs, and enhance manufacturability. A widely used software. Their software incorporates cost modeling. Specifically their DFM software incorporates this cost modeling, cost optimization, uh, via a thorough understanding of the primary cost drivers. Their DFA offers product simplification. The DFA software utilizes an intuitive question and answer interface that identifies opportunities for substantial cost reduction in a product. The components of their software focus simply on the product structures by reducing part counts, minimizing assembly steps, and leading to substantial costs, which in turn leads to a substantial cost savings and accelerated product development. Um, the DFMA software here, specifically the DFA, allows the engineers to compare cost uh, the DFM, sorry. The DFM cost allows engineers to compare the cost of producing alternative designs, providing which in turn just provides an early profile for product design. Uh, Moreover, it offers a unique approach to design analysis by quantifying the impacts of the design decision. This quantitative analysis aids in identifying cost-saving opportunities and making an informed, and it helps make informed design choices that enhance product profitability. It's successful. It's been successfully implemented in various industries, including automotive, aerospace, consumer products. I would say it demonstrates a versatility and effectiveness in improved design efficiency and reducing time to market. Uh, for instance, in redesigns in UAVs, it achieved a 51% cost reduction and a 74% decrease in assembly time. Quite significant. In essence, I would say that this software serves as a vital tool to optimize product design for manufacturability and assembly, both, which leads to cost savings and improved product performance. It has a great product architecture, and by reducing that per count reducing that part count while evaluating the cost effectiveness of manufacturing options. According to their website here, their approach has helped many companies save an overall assembly time by 70%, which has excelled in the quantifying cost impacts. Well, our next one is Siemens Technomatics. This software here provides more of a rich simulation environment for an end-to-end manufacturing. It enables the teams of manufacturers to model production lines, simulate worker tasks, and plan operations virtually. Unlike any of the other softwares, it's very it has a very it's very keen on smart factory planning and digital transformation. To provide more of an in-depth analysis, it's a more of a comprehensive digital manufacturing solution that enables manufacturers to design, simulate, and optimize production process in a virtual environment. It offers a suite of tools that are tailored for advancing manufacturing visualization, factory and line design, and manufacturing process planning. Specifically, more it ranges from a wide variety of applications such as electrical systems, electronic designs, lifecycle management, manufacturing, mechanical design, simulation and test, software development, and supply chain management. A little bit more in depth of its uniqueness. It offers a visualization capability, which leverages technologies like AI, um, AR, augmented reality, and VR, virtual reality, and point clouds to create more of an immersive simulation of manufacturing processes, facilitating a better decision making and process optimization. Factory line tool designs, uh, you know, factory and line design tools that are offered allow users to design, configure, simulate, and optimize a 3D factory layout and product lines, which in turn improves the utilization and operational efficiency. It also the software emphasizes on a human-centered design by incorporating virtual humans and ergonomic analysis into its simulations. It creates a very immersive environment for its manufacturing processes, unlike the other softwares, providing and enabling efficient execution of part and assembly planning activities. Uh, it facilitates through this. It facilitates a better communication and coordination among teams, reducing costly errors, acceleration time to market, and accelerates time to market. Its integration alone allows for that real-time monitoring. I would say in some, it offers a more robust set of tools for digital manufacturing, enabling these manufacturers to enhance productivity, reduce costs, and achieve greater flexibility in their operations. Our last software tool here is, in summary, brief summary, is a priori, which simulates production scenarios to inform design decisions. It has a unique feature of flagging costly features, identifying substantial alternatives, and it forecasts part pricing based on geometry and process. I would say in sum that this software, it bridges a gap between engineering and sourcing. Uh, to dive a little bit more in-depth analysis of how this software works, it's a digital manufacturing simulation software that provides a real-time insights into the product cost, manufacturability, and sustainability by leveraging 3D CAD models to automate and simulate the entire production process, thereby enabling the design and manufacturing teams to make a better decision throughout the product life cycle. It also offers these modules allowing design engineers to compare and assess multiple design variants, materials, and sourcing options, which provides a early insight into the cost, carbon emissions, and manufacturable issues. It's very a proactive approach that helps reduce the design interactions and accelerates the time to market. It has its system operates more on a cloud-based platform, uh, and it fosters a collaborative design, cost engineering, sustainability, and it sources teams by unifying the product data and enabling real-time communication. It, in that, just to say, it's a collaborative environment that ensures that reduces delays and late-stage engineering changes. It also supports a wide range of manufacturing processes, like in metal, casting, plastic molding, sheet metal fabrication, machining, welding. It does this, supports this by simulating these processes and identifies cost drivers and manufacturable issues early in the design phase, which, as been said, it's more profitable this way and creates a more of a sustainable product. Summary, very unique software that empowers these manufacturers to optimize designs, reduce cost, and improve sustainability, providing a more of an actionable insight into the manufacturer and costs as a stepwise process. Little bit of a summary of a comparative analysis of the unique differentiators between these software platforms. The DFM Pro, it's built in CAD. It's more of a CAD validation with design rule libraries based on 3D CAD models. Veo Pro provides a provides the depth of a PCB specific checks, and it integrates a visual feedback. DFMA is more focused on the part count reduction and quantitative assembly simplification. The Siemens Technomatics is a human simulation, ergonomics, and digital twin integration. A priori is a live cost modeling and carbon footprint analysis. Alrighty, so our last and final slide here is the key takeaways from each of these platforms, starting with the Veo Pro. It's built for PCB design. It catches issues like pad spacing, soldering defects, and component collisions before the prototyping by using their 1500 rule checks, which is ideal for an electronics team aiming to cut rework and improve first pass yield. The DFMA is all about design simplification and cost reduction. It helps teams cut part counts and assembly time, perfect for redesign efforts where lowering labor and tooling costs is a priority. A priori, it focuses on the cost modeling and sustainability. It incorporates and simulates a real world manufacturing and sourcing scenario directly from 3D models, showing how design choices can impact cost and carbon footprint. I would say that this one is more ideal for cost engineering and ESG aligned product teams. Uh, the next here is DFM Pro. I would say this one's more of a universal. It's an everyday engineer tool. It runs manufacturability checks directly into CAD platforms like SolidWorks. It's fast, rule driven, and it's great at catching features for complicated machining and molding casting. Complicated, machining, molding, and casting features. Lastly, here is the Siemens Technomatics. It's is a more of an enterprise grade solution. It simulates full production lines, workforce ergonomics, and platform layouts. So if you need, digital twins or smart factory planning, this software is unmatched. Uh, and then in short, Veo Pro for PCB reliability, DFMA cost cutting via design, a priori for cost carbon modeling. DFMM Pro is CAD manufacturability, and Technomatics is more of a factory scale digital planning. With that being said, this would be the conclusion of our session here, and I thank you for listening in.